Alright, hello and welcome to another episode of Things Digital online series. And we're looking at computer vision with Python again today. So today we're going to introduce another filter. It's called the Sobel filter, and it has a pretty interesting composition to it. So it does the filtering in the x-axis and the y-axis, x direction, the y direction, and then it will give output which will detect the lines in a certain direction. And if we combine the two at the end, we'll get combined image with both the x-axis detected lines as well as those detected in the y-axis. So to begin, let's start off with editing the code that we had at the end of the previous session's tutorial. And so we will continue to capture a frame and then apply a grayscale image filter to it, right? So what's unique about these Sobel operations is that it does a joint Gaussian elimination as well as a differential operation. So it is more resistant to the noises in the background and also is able to detect the lines in both axes and then combine them into one image. So the arguments are pretty similar. So what we do is we just create a new one for it. So maybe we call it the Sobel x-axis. We call it Sobel frame x. So CV2 Sobel. So we pass in the gray image, first argument. Then we pass something called CV2.cv underscore 4f. We'll talk about that later. 1, 0. So it's just the x-axis. And the kernel size, like what we talked about earlier about kernel size. So let's set it at 5. Right. So similarly, let's do one for the y-axis. 2.over frame 2.cv for f. So for this, it'll be different. So it'll be 0, 1. Kernel equals 5. Alright, so one argument I changed is actually k size, so that's how the naming convention is done. So this means the x-axis and the kernel size is 5. And similarly for the y, all the arguments are the same except for this 1 is 0, just swapped over. Right, so let's move on to look at how we can get an image from it. So we'll look at finding the gradient, absolute gradient of each of it. So we call it absolute. And then we'll pass in the Sobel frame to process the x and y axis. Right, so this one we do the same and we do it for the y one. Okay, so let's move on to do the final step. It's to merge the two together. So actually we can look at how each of it will look like as of now. So we can look at the gradient for the x frame. Let's take a look. Oh, right. Right, so this is the x-axis and the gradient for the x1, and then yeah, let's take a look at both the x and the y on together. But the reason why there's so much color going on is because I used the frame for, instead of the gray frame, I used the original frame which has color to it. So I think for the sake of making the image clearer and finding more definition and lines is the thing that we want to find, lines. So let's use the gray frame instead. And now let's print out both of them. So the y and the x. Okay. Let's go and alright, so this is the sketch in the y axis and then this is on x. So you can see the difference in the lines that in general you look at them, you can tell that lines, one of them is going across, one is maybe going vertical direction. So let's just close all these and we'll look at how we can combine these two into one frame that will give us all the lines that are detected in both the y and the x-axis. So to do that, we will use one function, maybe we call it combine global. And then for this, we'll do a weighted average of both frames. So we find 50% of each frame. So cv2.add weighted. So we take in both gradients and we will, the first argument will be this and the frame. The second argument is the weighted, the weight of the first frame. So it's 0.5 to mean 50%. And then we'll do the same for the y-axis and do a 0.5 too. So this will print out the frame by one for the last argument too. So here, let's take combine Sobel. And let's take a look at how the output is. So this is the Sobel frame that we have over here, and you can tell that from these, the background has quite a lot of noise to it, so we'll have to do setting up filtering and all later on. But then some lines are very distinct, you can tell. So let me just take a piece of foolscap picture. So apart from the noise, we can get pretty good detection of the lines. So in future, we can pass different kind of line detection to figure out certain lines that exist within a certain frame. And if you want to look at them, those lines that are vertical. So for example, road lines are mainly vertical, like in frame perspective, it's vertical. So we could possibly ignore the x-axis to give us a better output. So let's just close this and maybe we can take a look at the road itself. This is the frame, and we can kind of tell the lines a little better from this. So most of the background just appears as noise. So with the right thresholding in future, we can definitely pick up the lines a bit better. All this is all about experimentation along the way too. Alright, so just now we looked at the Sobel frame line and we passed in the function Sobel, and we put in this variable over here, which is 64f. So what it means is it's passing through a float value as the output. But we also can use the 8-bit unsigned integer, and let's take a look at what is the difference in the output. So just remember that if we use unsigned integers, the gradients are all not taken into account in terms of direction. So we lose the negative gradients that are involved in this image processing technique. So bear in mind, we do take the gradients in and all. So the frame that we get is a little different. Alright, so let's use some of the codes that we did in the previous tutorial, which is the merge frame. So we can combine two frames together to give us something that looks easy to compare just by the visuals of it. So we'll just do a vertical concat because we only have two frames to compare. So what we'll be using is the Sobel frame X8. Let's just give it two names, and let's just ignore these first, and the other one will be 64 float. Okay, so we change this to 64 float this. Let's also do the absolute gradients. Right, so let's just leave all this out for now. Alright, so just for comparison's sake, let's look at two frames combined together, side by side. So the one on the left will be the 8-bit unsigned variable frame, and the one on the right will be the 64-bit float frame. So let's take a look. So these are the differences that we have in the two frames. So the one on the left does not consider the negative gradients, so we lose definitely a bit of the kind of lines and images, but one thing for sure is that the lines still look very clear, the road lines. So this is for the x-axis. Alright, so that's about it for today's session. You can tinker around the code and look at the different variables and change certain things around, and then you will get different output. And definitely every variable could be changed to suit the kind of project that you are doing. So as we go along, we'll be experimenting, tinkering around with these values over here. Alright, so that's the end of today's session. If you would like to follow along with the code and then play around with different variables, you can find the code in the comment section. And next, we'll be looking at different kind of transforms. So till next time, bye bye.